Start with an apology. Our first 6 segments this morning, we couldn't Zoom. Zoom was down. There are videos from previous semesters on how to do this. And we went the other direction for the first 6 activities where we were given a name and we had to draw it. And now we're going to have to go backwards and name these. And you have to remember, before they were these rings, this bond was made here and this bond was made here. So we're going to unravel things. That used to be an OH. And this used to be a carbonyl. Similarly, over here, used to be a carbonyl and an OH. Now I got an amino group here. So remember, before you made these rings, you had to do a rotation from the fissure to get it into a ring. Here you've got to get it rotated back so that all of the carbons in the chain are in a loop. The loop goes around this way, starting carbonyl. There's the carbon loop. So clearly this carbon needs to be rotated there to get it back into the loop. The O needs to rotate to where the H was, and the H needs to rotate where that is. And you're getting your carbons back in the loop. CH3 there, OH down here, H up here. Everything else stayed the same. This was just sigma rotation. There were no changes, no switching, nothing. Just rotating. And you should be able to get a fissure from that. Remember the expression darn right means everything that was down here will be on the right in the fissure. And there's the uplifting experience. Everything that was in the up position here will be on the left of the fissure. So the fissure is here. Down is to the right. Up is to the left. Up is to the left. Down is to the right. And this has CH3 here. None of the sugars has a CH3 down there. 1, 2, 3, 4, 5, 6. This is a 6-deoxy. And I'm going to let you fill in this for me. I will wait for your answer. Stereo centers go right, left, left, right. Anybody? Say it again. Galactose. So one major point for your answer is to figure out that this was a galactose sugar. And I'm ready for my name, but I need to see the original now. I didn't put a methyl. There was she asked, why did I put a methyl there? Well, I didn't. There was a methyl from the original question. And the only reason there's not an OH on there is because this is a deoxy on position 6. That will be in the name. So the name of the sugar is, once again, this O is up the carbon off of the ring. We can't use CH2OH off of the ring, but the carbon's there. They're cis to each other. This is a beta sugar. Beta, 6, deoxy, D, galacto. Is it a furan or a pyran? Ring size 5 is furan. This one is ring size 6. pyran. Is it an os or an oside? If it's a hemiacetal, which this one is, it's an oside. If it was, sorry, I'm sorry. If it's a hemiacetal like this one is, it's an os. If it's a full acetal, then it's an oside, and we don't have one of those on the stage. So we're going to continue our work on the other one that we didn't finish. Similar rotation. I need to get the CH2OH back in the loop. That means the direction of rotation is thus. And I think I can go straight to the sugar. Uplifting. There's an amino instead of an OH there. And downwriting. Back in the loop. That gets you there. I skipped drawing this step on this example. I went straight from here to here. After I realized the OH ended up down, I put it here. And then the H ends up uplifting. I didn't draw it. I could put it here just to make you maybe a little more comfortable there. So find the sugar where there's an OH here. Is it D-fructose? Yeah. Okay. And remember, that's position 4. So you say 4-amino. 4-amino. D-fructose. So your final answer in blue, and once again, we got to do the alpha beta. This O is down, which is trans to this CH2OH, which is up, which means it's trans is alpha. Alpha for amino D-fructose, and this one's a 5-size ring. Fructose, furanol, and it's a hemiacetal. These are our final answers. They need to have boxes. Once again, I'm only going to grade your final answers. Whoa, thought that was triangle, huh? Okay. Coming back for more.